This is the basic setup I used for handgun rounds. Thick, cooked beef bone followed by water jugs. I know some people are going to get hung up on the fact that the bone is cooked and not raw. However, this bone is still very dense and hard. To illustrate this point, I shot beef bone at 15 yards with number 4 Rio buckshot from an 18.5-inch barrel. It gave very superficial damage. It didn't show up well on camera, but there was a lead mark on the bone where a pellet seemed to have come apart on impact. Then I shot the same bone from the same distance of 15 yards with Winchester Super X 9-pellet double-aught buckshot. The result was noticeably more damage to the bone, but it was not nearly enough to have any meaningful effect. Likewise, other people have shot bear heads from a distance of 15 yards with double-aught buck and found that the pellets did not penetrate through the skull and into the brain itself. One of the things I wanted to know was how much penetration less powerful rounds would have after hitting thick bone. So I shot a Winchester Wildcat lead round nose .22 from a rifle. The bullet got significantly deformed but went right through the bone and was found in the second water jug behind the bone. I shot that same Winchester .22 ammunition out of a 3-inch barreled revolver this time, and the bullet was found in front of the bone on the pallet itself. I apologize for the poor camera work. This was the first time I had filmed something like this. I shot the bone a couple more times with regular lead bullets from the .22 revolver, and then I used a CCI Mini-Mag copper-plated round nose. One of the rounds, I believe it was the Mini-Mag, actually made it through the bone and stopped in the water jug behind it. I also shot the copper-plated Mini-Mag round through a rifle. This bullet passed through the bone and the water jug behind it, before stopping on the bag of water behind the jug. I shot a Winchester USA, or Winchester White Box, 110 grain .357 Magnum jacketed hollow point through the bone from a 2-inch barreled revolver. This bullet stopped after passing through a single water jug. I should also mention that this round broke the bone in half on impact. For the sake of comparison, I then shot that same .357 Magnum round through only water. This time it penetrated through 2 1-gallon bags filled with water and then stopped in a quart-sized bag. I had some original 158 grain Federal HydroShock 38 special rounds as well. Again, I'm using a 2-inch barrel. I aimed a little too low with this shot, so this round took a splinter of wood and drove it into the water jug. This bullet had considerably more expansion than the one that went through bone. The reason why this happened, in my opinion, is because it merely glanced off the wood and hit the water jug with most of its force. When I fired again, this HydroShock hit the bone, penetrated right through 2 jugs. Then it nicked a jug and lodged itself in the front plastic of jug 3. These are the 2 .38 special HydroShocks next to each other for comparison. Behind them are a couple of 240 grain .44 Magnum hardcast lead rounds. I shot 2 of these 44s into bone. One just hit the edge and the other completely destroyed the bone. I do not believe either round had significant fragmentation on impact, or I would have been able to catch at least one of them in the water jugs. This is quite interesting considering the fact that hardcast rounds that other people have tested have shattered on less bone than this. Since I used a 7.5-inch barrel, these rounds had considerable velocity. This leads me to believe that some hardcast lead alloys are considerably better than others because even high velocity did not make these rounds fail. I would not be able to tell you what alloy works better than another, nor would I be able to tell you what is the best off-the-shelf ammunition that you could buy today. The rounds that I have are not made anymore. More testing would answer more questions, but frankly, I don't have the budget for lengthy tests right now. Finally, I shot a regular .38 special lead round nose bullet from a 2-inch barreled revolver, and it went through this bone and at least 4 water jugs. It exited and was not recovered. So in conclusion, when shot from a rifle, a .22 can go through a considerable amount of bone, but have little penetration afterwards. With a powerful handgun like a .44 Magnum, you can shatter bone even with non-expanding rounds. The point I want to really stress is that bone is not completely consistent. It is thinner in some places than others, which is why I don't think we should just be testing in bone. Ideally, we'd want to also be testing bullets in a consistent substance that behaves very similar to bone so we can do repeatable and accurate comparisons. Wood is too soft, and I believe that some sort of ceramic would most accurately represent bone. Finally, regular full metal jacket handgun rounds seem to have little or no deformation in thick bone, so if you don't know if a given hard cast round will stay together or not, you may choose to use a full metal jacket or solid copper round instead. Since I mentioned using ceramic to represent bone, I want to elaborate a little. Both of these are 180 grain Buffalo bore hardcast rounds in .357 Magnum. One round was shot into a ceramic dinner plate with considerable velocity, yet it stayed together. The other bullet had less velocity and yet still came apart on impact with a pig femur. So a ceramic plate doesn't nearly give the same resistance as a pig femur does. In comparison, this was a .357 SIG full metal jacket that was shot into two ceramic tiles, roughly 1/4 inch thick. Obviously, these ceramic tiles have more resistance than thick bone does, so such a test is not particularly helpful for choosing bare defense ammunition. Likewise, if you shoot into a ceramic tile and you get expansion from a full metal jacket round, that's clearly not representing bone. The round on the top was a hardcast .45-70 that was shot into ceramic tiles. The one on the bottom was a hardcast .45-70 that penetrated through the thick part of an elephant's leg bone and through two buffalo shoulders. It's obvious that ceramic plates have far more resistance than very thick and large bones. I don't think it's difficult, though, to find a piece of ceramic that would represent bone. Bullet construction obviously matters for expanding rounds, but you don't need a really high-tech or expensive bullet to do well through bone. This was a Remington UMC .357 Magnum semi-jacketed hollow point that was shot into a pig femur at 1,501 feet per second. When you have really flat, overexpanded bullets, that's the sign that the velocity is too high for the bullet design. This is the same type of bullet shot from a 2¼ inch barrel, and you can see that 1,302 feet per second of velocity still gives plenty of expansion, but not huge, uncontrolled overexpansion. This was a 40 Smith & Wesson Federal HST 180 grain round that was shot into a pork femur and water jugs. The impact velocity was 984 feet per second. This was fast enough to cause the bullet to noticeably deform and squish on impact with the bone, but apparently not fast enough for the bullet to expand in the water after passing through the bone. If we took that same bullet and shot it at a higher velocity, say from a 10mm handgun, that would give actual expansion and a significantly different outcome. In comparison, this was a 9mm 124 grain plus P plus gold dot shot from a relatively short barrel. This is a bonded round, so it's still mostly staying together. However, it's still badly overexpanding at this velocity. The advantage of bonded bullets is that they don't start to fragment and totally lose their shape like some unbonded rounds can. When a regular jacketed hollow point loses its jacket, that's not a complete failure. As long as the lead core of the bullet doesn't overexpand and underpenetrate or start to fragment, it will still get the job done. A problem that I've noticed is that people will get very focused on the velocity or foot-pounds of energy that is listed on the side of the ammunition box. They make the mistake of assuming certain numbers automatically give you better performance. In reality, you can't tell what kind of performance you will have unless you actually test that ammunition, so we shouldn't make the assumption that more velocity is always better, because at a certain point it can cause overexpansion and underpenetration. The goal should always be to use the right bullet at the right velocity. We can also state that bullets that have exposed lead tips, like jacketed soft points and semi-jacketed hollow points, are less dependent on velocity for good expansion after hitting bone. This is because such rounds tend to expand on hitting bone and other hard surfaces where a jacketed hollow point may not.